Oh man, I'm late for work again. My boss is gonna get so mad at me. See, navigating a city like Toronto with real-time precision shouldn't require juggling Google Maps, Waze, and five other open tabs. That's ridiculous. What if AI could plan your routes, track real-time traffic, and even optimize for weather, accidents, or construction? See, now that's what I'm talking about. In 2023, Toronto drivers wasted an average of 118 hours stuck in traffic, which is equivalent to nearly 3 full work weeks lost every single year. See, my last article talked about building a mini autonomous vehicle, but now it's time to take it a step further by building an AI which helps you navigate through different areas and differentiates itself from all of the navigation tools by providing reasoning on why it is selected such a specific route to get to your destination and efficiency. See, AutoPilot GPT changes that because being built with the power of AI, it transforms a simple question like fastest route to Pearson right now. Let's try it. As we can see, it gave us the route with like a human-like response, drawing from live traffic and roadwork data. This isn't any type of concept because it's real and built with the goal of making urban navigation just make sense. See, modern navigation apps, they're powerful, but they weren't designed to think like a human because they were designed to process coordinates. People don't realize this, but that's a huge difference. Thought processes of people who may believe this may sound like, get me to Pearson, but avoid Gardner if there's an accident. Take me somewhere nice for a walk that isn't crowded at the moment. And here's where a ton of current tools fall short. They're too reactive, more than being actionable. Apps like Google Maps, Waze, and Apple Maps generally respond to traffic once it's already bad and has been reported by other users, rather than predicting it themselves. That's a huge difference. Let's keep that in mind. And critical data is everywhere. Traffic, construction, and events are often handled in separate apps, which results in users having to deal with these issues while driving. They also caused costly mistakes. 60% of GPS users reported missing a turn due to unclear or delayed instructions, especially on highways where this can result in a lot more time being taken. And there's also a lack of understanding in instructions. If you type quickest route to Canada's Wonderland, avoiding tolls and poor weather, most apps cannot balance the priorities. In cities like Toronto or Mississauga, these issues mean the average traveler spends 46 minutes per day in traffic, over 180 hours a year, just enough to binge watch The Office twice. Now I want you to meet AutoPilot GPT. This is an AI-powered co-pilot built to understand why people move and make travel decisions, targeting the GTA. Instead of boxing you into rigid drop-down menus or filters, it listens to your request exactly as you'd say it out loud. See, at the rock bottom, Autopilot GPT fuses the reasoning capabilities of OpenAI's GPT-4 with live traffic feeds, hyperlocal weather forecasts, and up-to-the-minute mapping data. Access to real-time traffic info can reduce travel time by up to 20%. That's insane. Whether it's finding the fastest way to CNE right now, avoiding the construction and heavy rain, it gives you precise, optimized route in seconds. Now, some unique features on Autopilot GPT. See, so there's conversational intelligence. You can phrase requests naturally or use preset commands, whatever to your liking. Now there's also context-aware routing, where routes factor in traffic, constructions, accidents, and weather before you even get there. And lastly, there's personal preferences, avoiding tolls, taking scenic routes, and having it remember your exact style. So even though Autopilot GPT looks simple on the surface, the tech stack is built for speed, scalability, and accuracy. Now, if we look on the GitHub repo, we can see vite.config.ts. This configures Vite, a modern build tool that launches the app in milliseconds and rebuilds instantly when code changes by the user. This is critical for an app where rapid testing and iteration are needed to refine real-time features. Now, if we go to tailwind.config.ts, we can see that this is where it defines where Tailwind CSS should scan for class names, ensuring that only the styles used are included in the final build. Now, this makes the interface light, responsive, and mobile-friendly, important when your audience is often checking routes on the go, not having a laptop on access with them. Now, if we go to the explore.tsx, we can see that East comes to life as it handles predefined location requests, as this means with a single click, a user can get directions to a high-demand location like the CN Tower or maybe even Pearson without typing any words. Each of these triggers a GPT prompt under the hood, feeding relevant data coordinates into the AI before fetching route data. Now, if we look at chatinput.tsx, we can see that this is the heart of user interaction. This component listens for text input, ensures empty messages aren't sent, and forwards clean queries into GPT-4. It also adds a layer of validation to prevent malformed requests that could confuse the AI. Now, going back, we can see that the API integration layer connects Google Maps Directions API, the Traffic API, and Weather API directly to GPT-4. This fusion lets GPT reason, this is really important, about not just the shortest path, but the best path given the current conditions, such as traffic, weather, or any other circumstance. And now, prompt engineering. This is carefully designed by GPT prompts to reduce hallucinations and ensure AI sticks to real-world locations and reliable data sources. This architecture means AutoPilot GPT can be scaled to any city by swapping the traffic and mapping data sources without rewriting the core logic. Now, you might be wondering the biggest hurdle in this project. Obviously, the button on the Explore page didn't work initially, and clicking Get Directions to CN Tower. This was a big button on the UI page, if you remember, and this often did nothing or either crashed the entire app. Now, the solution for this was that each button triggered a pre-formatted GPT prompt. This cached for speed and API cost savings. Some other hurdles consisted of LLM hallucinations with fictional places or API rate limits, this was a huge one, and ambiguous inputs like take me to Pearson, needing clarification on where you're starting from. Now, you might be wondering why this matters. Well, Toronto ranks 7th worst in North America for traffic congestion. Globally, congestion costs over $1 trillion annually. The World Economic Forum projects AI integrated transportation systems that they could reduce global congestion by up to 25% by 2030. This shift will fundamentally change how cities operate, and AutoPilot GPT is a step toward that future. Now, what's next? While version 1 of AutoPilot GPT is still GTA focused, the architecture can work anywhere with the right data. See, the next steps include multimodal routing, which includes buses, subways, ride shares, all in one plan. And this also includes proactive alerts, getting notified of closures before they affect you. To sum it all up, this is an AI navigation tool that understands natural human requests, combines GPT-4 with real-time traffic, weather, and mapping data, and delivers personalized routes instantly. It's built with Vite, React, TypeScript, Tailwind CSS, GPT-4 API, and Google Maps API. It's fast and adaptable, which is what we need. Try AutoPilot GPT down in the description today.